Scrape your knee on the sidewalk, and almost immediately you feel a sharp sting. Within minutes, the area gets warm to the touch, and a bright red patch appears. That redness and heat signal a shift in focus. Your body has pivoted from the trauma of the fall to an active rescue mission. The exact second the skin breaks, the cells that get injured act like tripwires. They instantly release a flood of specific chemical signals into the surrounding tissue to announce a breach in the body's perimeter. Sitting nearby are special guards called mast cells. You can think of mast cells as the local fire alarms of your tissue. As soon as they detect those distress signals from the injured cells, they activate and scatter their own chemical beacons deep into the tissue to call for heavy backup. That rapid, localized cellular reaction sets the stage for a massive, highly coordinated biological rescue operation. We call this entire process inflammation. To get the right rescue crews to the scrape, the body needs a clear path. Those chemical alarms released by the mast cells drift downward through the tissue until they hit the nearby blood vessels. In a healthy state, these vessels are narrow, but when the alarm hits them, the walls of the blood vessels relax and expand. This widening creates a sudden, dense rush of extra blood flowing directly toward the injury site. Because blood is warm and carries a rich color, packing a massive volume of it into one specific area brings a sudden flush of heat and a bright red tint to your skin. The expansion of the blood vessels also causes the walls to stretch. The individual puzzle-like cells that make up the vessel pull apart slightly, creating tiny microscopic gaps. This allows protein-rich fluid to leak out of the bloodstream and flow directly into the damaged tissue. As that fluid pools into the surrounding area, the tissue fills up like a water balloon. This physical swelling pushes outward against your local nerve endings, creating that familiar throbbing sensation. The extra heat, the flushed skin, the puffiness, and the throbbing ache are all physical trade-offs required to widen the roads and open the biological highways for the first responders. The primary frontline defenders to arrive on the scene are specialized white blood cells called neutrophils. Following the chemical trail, a neutrophil attaches to the vessel wall, squeezing its body through the newly formed gaps into the tissue. Once they arrive, they behave like hungry vacuums. Neutrophils immediately begin hunting down any invading bacteria that slipped in through the broken skin, aggressively consuming the intruders to stop an infection. That fluid leaking from the blood vessels also carries a secondary network of backup tools, a family of floating tag and destroy proteins. This system acts as a direct support unit for the neutrophils. These specialized proteins identify threats and lock directly onto the surface of an invading bacterium. Once attached, they work together to literally punch physical holes straight through the outer shell of the invader, destroying it on the spot. Between the neutrophils consuming the invaders and the protein tools breaking them apart, the immediate threat of infection is neutralized. The perimeter is secure, but the fight leaves behind a chaotic, microscopic battlefield. The tissue around your scraped knee is now cluttered with wreckage. There are dead skin cells, destroyed bacteria, and the remains of the neutrophils that exhausted themselves during the fight. To handle this, the body brings in a specialized heavy-duty cell called a macrophage. If neutrophils are the frontline soldiers, macrophages are the biological garbage trucks. A macrophage slowly sweeps across the battlefield, systematically engulfing all the lingering cellular debris and digesting it into harmless raw materials. You cannot build a stable structure on top of a pile of rubble. Clearing out every last piece of microscopic waste is a strict, non-negotiable requirement before the body can begin to repair the physical damage. With the hazard removed and the site completely cleared of debris, the environment is finally stable. The emergency phase ends and the rebuilding phase initiates. The site is handed over to a group of cells called fibroblasts. These are the construction crews of your internal world, responsible for physically mending the broken tissue. As fibroblasts cross the empty space, they manufacture a sturdy protein called collagen, layering down strong fiber strands to bridge the gap. To feed them, tiny new blood vessels sprout to deliver fresh nutrients, then recede and vanish once the structural work completes. The final outcome depends on the severity of the original wound. For a minor scrape, the tissue usually regenerates perfectly back to its original state. But if the damage is severe, the construction crew has to lay down an incredibly dense layer of collagen, leaving behind a permanent fibrous patch we recognize as a scar. Looking down at your knee a few days later, you will notice the bright redness has faded, the heat is gone, and the puffiness has subsided. Those uncomfortable symptoms demonstrate the security system in action. The intense warmth, the visible swelling, and the ache serve as evidence that your internal resources are being deployed exactly where they are needed. Inflammation is a coordinated effort of millions of specialized cells communicating across a microscopic landscape to protect, clean, and rebuild human tissue.